Hello everyone, how's it going? In this video we will take a look at inheritance in Kotlin. So let's talk about inheritance. Inheritance is one of the key features of object-oriented programming. It allows user to create a new class from an existing class. The derived class inherits all the features from the base class and can have additional features of its own. The class from which the features are inherited is known as the base class, or a superclass, or a parent class. And the class that inherits the features is known as the derived class, or the subclass, or a child class. So we saw what is inheritance. Now we are going to take a look at why it is needed. So let's understand this concept with the help of an example. So let's say we have three classes. And we have a dog class, a cat, let's write it, a dog, a cat, and we have a horse class. All of these classes have some properties which are called data members and some behaviors. So for example, a dog can eat, sleep, bark, etc. So for example, for the dog class, we have some properties, for example, the color, we have the race, then we have some behaviors. For example, it can eat, it can sleep, and it can bark. And in a similar way, we have some features for the cat class. So we have like cat has also color, race, and the cat can also eat, sleep, and it can not bark, but let's say meow. And in a similar way, we have some properties and behaviors which are in horse class. So I'm going to delete this for now. So we can see that we have few properties and behaviors which are common. So for example, this color property and race, this is common for dog and cat as well. And we have some behaviors like eat and sleep. These are common for the dog and cat class. So why not we make a generalized class with common properties and behaviors and let these two classes inherit that generalized class. So that is the basic idea behind inheritance. So for example, we call this generic class, let's write it here. We call this generic class animal. And the common properties and behaviors, we can list them in animal class. So color and race goes inside this class. And for common behaviors, we have eat and sleep. So now the color and race properties which are common in both the dog and cat class, we have moved these properties to animal class. And now we can remove this from these classes. And in a similar way, we can remove the behaviors that are common to both classes. For example, eat, we can remove that. And we can remove this eat from here. And we can also remove the sleep behavior, which is common for both the dog and cat classes. So now we are left with bark and meow, which are the unique behaviors of the dog and cat class. So here we can see we have moved the common properties and behaviors in a generalized class, which we call animal. And we have left the behavior which are unique to dog and cat class inside their own class, like we can see here. So that is how inheritance is used. So we can say that dog class inherits all the features of animal class, and adds an additional feature, which is this bark. And in a similar way, cat class inherits all the features of an animal class and has its one unique behavior here. So the advantage of inheritance is we don't need to implement the same code for race, eat, and sleep for each class. We just need to inherit them. So this means that we are reusing the functionality that is common to both the classes instead of defining eat and sleep function in the classes individually. It is important to remember that when working with inheritance, each derived class or the subclass should satisfy the condition of whether it is a base class. So in this example, we can see cat is an animal and a dog is also an animal. So there is a relationship between these two classes. So let's just write the above logic in a Kotlin program. So we are going to create a class called animal, and then we are going to create two more classes, a dog and cat, which will inherit the animal class. So I'm going to write the code first, and then we'll walk through the code to understand it in a better way. So to start, I'm going to remove all this. And here we are going to create a class called animal. And inside the constructor, I'm going to pass two parameters. So the properties that were common in the both classes. So that was color, which will be of type string. And then we have the race, which is of type, let's say, string. So here is our animal class, and I'm going to write an init block. Inside this, I'm going to write two print statements. So color is, let's print the value of color, and print ln. Race is, let's print the value of race. So here we have defined our animal class. Now we are going to create the dog class. So here I'm going to type class dog, and this will have a color property and a race, which will be of type string. And the dog class will have a function, and we call it bark. And let's print one statement inside. Dog makes a sound of bark. Or let's call it dog barks. And finally, we are going to create a cat class. Here we have a color, a race, and here we have a function called meow. And for this, I'm going to write a print statement saying cat meows. Alright, so we have defined our three classes, and now we are going to take a look at how we can inherit the animal class. So by default, the classes in Kotlin are final. So if you are familiar with Java, you know that a final class cannot be inherited. So we are going to make this class inheritable. So for this, I'm going to type open. So by using the open keyword, we are making the animal class open, so which means that this can be inherited by dog and a cat class. So to make the dog class inherit animal class, we are going to type a colon, and then I'm going to type animal, so which means that the dog class inherits animal class. And in a similar way, we are going to type colon and type animal in the cat class, which means that cat class will inherit from animal. So here we can see we have an error, and the error basically says that this type has a constructor and thus must be initialized here. So which basically means that if the derived class contains a primary constructor, then we need to initialize the base class constructor using the parameters of the derived class. So we have two parameters in the primary constructor of the base class, color and race. So these parameters must be initialized right here by calling the primary constructor of the animal class. In other words, if the derived class has a primary constructor, the base class must be initialized right there using the parameters of the primary constructor. So here we are going to call the primary constructor of the base class, and we will pass color and race here. And the same goes for the cat class. We are going to call the primary constructor of animal class, and we are going to pass color and race. So now we are going to write code inside the main function. So I'm going to create an object of, let's call this val dog is equal to dog class, and I'm going to pass, let's say, black for the color, and let's pass in here like. So for the race or breed, we can pass, for example, let's pass here husky, and let's call a function of dog class, let's call bark. And we are also going to create an object of cat class. Let's pass white for the color, and let's pass in Persian for the race. And I'm going to call meow function on cat object. So let's run the program, and let's see what do we get in the output window. So here we can see we have color is black, race is husky, dog barks, color is white, race is Persian, and cat meows. So that's how we use inheritance. So we are reusing the variables color and race, and we have the unique behavior of each class like dog barks and cat meows. So the common properties are defined in the animal class, and the unique properties are defined in their respective classes. So one important thing to note is that the primary constructor of the base class declared two properties, color and a race, and it also has an initializer block. The init block of the base class can be accessed by the objects of the derived class. So we are calling the init block of the base class by the object of the derived class, which is dog in this case. And the derived classes dog and cat have their own member functions. These functions are accessible only from the object of their respective class. Means a meow can only be accessed by the object of cat class because this is unique to this class. So let's see this in action. So if we have an object of animal class, like, let's pass some random stuff here like brown, let's pass here XYZ. Oops, I missed the equal sign. So if I type animal dot, and here we can see we don't have the function that was bark and meow in this case, because that function is unique to the derived class and we cannot access it using the object of animal class. So let's remove this. So what happens is if we don't have this primary constructor in the dog class, for example. So I'm going to remove this, and I'm going to create a secondary constructor. So let's type constructor, and here we have color, string, and race, which will be of type string. So in case of no primary constructor, each derived class has to initialize the base class using the super keyword. So in case of a primary constructor, we are initializing the base class right here, and in case of secondary constructor, we have to initialize the base class using the super keyword, and we have to pass in the value of color and race, and we are going to remove this constructor call here. So if the derived class has no primary constructor, then each secondary constructor has to initialize the base class using the super keyword or to delegate to another constructor which does that. So if you run the program again, we'll get the same output. So our program is up and running, and here we can see we have the similar output as before. And now we are going to take a look at overriding properties and functions of a base class. So a child class can override the member function of a parent class using override keyword. By overriding a function, a child class gives its own implementation to the already existing code of the base class. So overriding doesn't mean that it will update the code in the base class. The change is only applicable to the class overriding the function or its subclasses. So let's understand this with the help of an example. So for example, in the animal class, we have a function. So let's remove the constructor. So let's say we have a function called fun make sound. Let's call this sound. So here we have to write a print statement, and I'm going to pass in animal makes a sound. I'm going to remove the init block. And let's say we have a dog class which extends the animal class. I'm going to remove this constructor call here, and instead of, I'm also going to remove the constructor. So let's override the function that we define in the animal class. So instead of defining an own function here, we can override the function sound. So to make a function available for overriding, we have to append the word open before the function. So by using the open keyword, we are making this function as overridable. And in the doc class, I'm going to use the override keyword, and then I'm going to write the sound function that we are going to override. So dog makes a sound of a woof. I'm going to remove cat class for now. Okay, so in the main function, I'm going to create an object of dog class. And let's call the function dog.sound. And let's run the program, and we'll see what we get in the output window. So here we can see a dog makes a sound of woof is printed down in the output window. So what is happening is we are overriding the function a sound which is defined in the animal class, and we are calling this function using the dog object. So by using the dog object, it will check that the type of object is dog, so it will call this overridden function which is inside the dog class. So here dog.sound will call the sound method of the derived class. Okay, so now we are going to take a look at how we can override properties. So let's define a property in the animal class. Let's remove this function, and let's define a property called color. This will be of type string, and let's set it to white. And let's override this property using the override keyword, and we're going to type var color string equals, let's put black in here. So we are going to create an object of the dog class. So let's type println, and inside this function I'm going to print the color property for dog, so dog.color. So let's run the program to see the output. So here we can see we have a black printed in the output window. So remember, we have to use the override keyword with the properties as well, like we did with the functions. So that's how we override a property in Kotlin. So now let's take a look at how we can call the data members of the base class from the derived class. So we can call the functions of the base class from a derived class using the super keyword. So to see this in action, I'm going to copy and paste some code. So let's paste some code right here. So here we have a bird class and we have a parrot class. The parrot class basically extends the bird class. Both have a property color, and here we have a function of fly in the base class that we are overriding in the child class. So let's create an object of a parrot class. and let's call p.fly. So here we are calling p.fly function, which we have overridden in the parent class, so it will call this function. And we are using the super keyword to call the parent class implementation of the fly method. So the super keyword .fly, with this we are calling this function that we have defined in the parent class. So let's run the program and let's see what do we get in the output window. So here we can see we have a bird is flying and a parrot is flying. So upon execution of this fly function, the super call is made, which calls the implementation of the fly function in the parent class. And then this line runs, which prints parrot is flying on the output window. Alright, so that's it for this video, and in the next video we are going to take a look at getters and setters in Kotlin.